O'Reilly's.
So mark your calendars accordingly.
What about the retreat kids?
When they get back,
What about their, when they get back?
any day next week, any day next week. All right. So again, I encourage you to find your percentage, your real percentage. So subtract 2, divide by 16, and you got to do better than that on test day. Right? A 16-point quiz isn't going to kill you, but you know, you get a 52 on a 100-point test, and that can be bad. So we are going to do better. All right, so here's my first process. Was there anyone who got every single part of this problem right? I didn't think so. Outrageous. Here we go. We're going to get it right next time. We already did a couple of these. I would suggest we start by factoring. So we'll take a 2 out of that top. So here's how it factors. This is an easy factoring. I encourage you, however, if you struggle with factoring, be sure that you FOIL your factors back out to make sure they're correct. Because what happens if you factor wrong? Everything's going to be wrong. Because all these answers depend on the factors. Now, I notice right away that I can cancel. So my problem becomes this. All right, now lots of things right from the get-go. See this right here? What does that tell me? My horizontal asymptote is y equals 2. Okay? Now, let's look at what's left after we do all this canceling here. See that denominator right there? What does that tell me? Vertical is x equals 4. And then this right here tells me that I'm going to have a hole where x is -3. So then I'll plug it in right here. 2 times -3 plus 4 over -3 minus 4. And it looks like I get 2 over -7.
Yeah.
Okay? Now, intercepts. Intercepts are where we cross the axes. So a y-intercept is 0, comma something, and an x-intercept is something, comma 0. So to find the intercepts, you just let each letter, one at a time, be 0. So if I want this guy right here, I'm going to let x be 0. So here I am. I'm going to put in 0 for x. So if I put in 0 for x, I get 8 over -4. I'm putting in zeros, which is 2. That's a negative, yep, -2. So -2, comma 0. That, or 2, that's right. 0, comma -2. I put 0 in for x, and I got -2 out of that. So that was this one. Now to find this one, I'm going to put 0 in right here. So I have 0 equals basically 2x plus 8 over x minus 4. When I solve that, I'm going to multiply both sides by x minus 4. So So 0 equals 2x plus 8. I'm going to subtract 8, divide by 2, and my intercept, my x-intercept, is negative 4. This point right here is negative 4, comma 0. All right, does anybody have a question about that? Oh, from the denominator can't be 0. So what we do is the denominator 0. All right, number 2. What a disaster for some here. Let's look at the picture. While I'm drawing it, maybe you could be trying to figure out what you did wrong. All right. Here we go. We want the domain. Take a look at this thing. Take a look at this thing. What's the domain?
All real.
All real. What's the range?
Negative infinity.
It goes from negative infinity up to here, right? So negative infinity to 3. And that's where your graphic is, because there is a point at negative 3. All right, local or relative maximums. Local and relative are the same thing. The relative maxes happen where? Looks like I got one right here. So that is negative 2, comma 3. Looks like I have one right here. 0, comma 1. Those are points. They're not intervals. These are actual ordered pairs. This point or this point. And then it looks like I have another one at 4, comma 0. Relative things are tops of hills, bottoms of valleys. So that's a top, that's a top, that's a top. Absolute maximum. The absolute or global maximum is the single highest point on the curve. Does this curve have a single highest point? It does, because those arrows are going down. So that would be negative 2, comma. Does this curve have an absolute minimum? Absolute minimum. No, because the arrows are
Going down.
going down. Does this have a relative minimum? Yes.
Yeah.
It would have one right here, right? It would have a couple of them right here, and that would be it for minimums. All right, and then finally, where are we increasing? Now, these are intervals. So, start over here. Start following the curve. Isn't my pencil going up the entire time? And I'm moving left to right. So left, or right, I mean, I'm going right. From left to right. So I'm looking at x values. X values. So from negative infinity to negative 2, my pencil is going up. From negative infinity to negative 2, I'm going up. Now, where do I start going up again? Right here? So that's negative 1 to 0. Where do I start going up again? Right here? 1, 2, 3 to 4. There are the 3 places on the curve where if you actually draw it, trace over it with your pencil, you will be going up. That is increasing. Got it? All right, backside. What is the domain of this function? Now, you don't have a picture, so you're going to have to look at the equation. What are the red flags or the limiting things in your equation when we talk about domain? What do we have to pay attention to? Radical and denominator. Okay? The denominator tells me that whatever happens, x cannot be 2. And then the radical tells me that whatever is under it has to be positive, bigger than 0 or equal to 0. Because if it's negative, what happens? I get i's, and we don't want i's. So x has to be bigger than or equal to negative 5. I like to draw a picture of this. Here's negative 5. I'm bigger than or equal to negative 5, except I can't be 2. So I look like that. So what's my domain? Negative 5 to 2, and then 2 to infinity. So everything from negative 5 on except skip 2. All right, we okay with that? All right, even, odd, or neither show your work. Okay, so even means we have symmetry to the y-axis, which means we change the sign on x. Okay, so I'll do that. So p of negative x will equal 2 times negative x cubed minus 4 times negative x plus 1. So I just take out the x's and put in negative x's, and then I simplify. All right, so what is this term? When I clean that up, that term will be negative 2x cubed. Ooh, what's going to happen here? Plus 4x plus 1. Now, if I'm even, then when I change the sign on x, I'm supposed to get my original problem, right? I'm supposed to get this back again? Did I?
No.
Nope. P of negative x doesn't equal P of regular x, so not even. All right, what's the test for odd?
If it's negative, or if it's the complete opposite.
So I'm gonna change the sign on y, I'll call that y to make it easier for you, and change the sign on my x's. Okay, so for odd, it's origin symmetry. And I'm going to change the sign on both. And what's supposed to happen? When I simplify, it gives me back this right here. All right, so let's see if that happens. Oh, shoot. It's close. Not quite, right? So, didn't match original. So not on. Therefore, this one is neither.
I put neither, you said I didn't answer it right.
Well, did you explain it like I did? Does you
Yeah,
guys see all that
I
on
said
there?
the equation above is neither because it's not.
All right, I'll look at it and see. Chances are, no, it's not even. But I'll look at it and see.
So if we say either it doesn't have symmetry, or it has no symmetry, that's still wrong.
Again, saying it has no symmetry, I don't know. You haven't checked for all symmetries. You checked for only y-axis and origin. So it has no y-axis symmetry, it has no origin symmetry, but you didn't check for other things.
So if I said it has no y-axis or origin,
And you have this kind of work there, yeah, I have to see that kind of work. All right, what is the end behavior of the exponential function? Now, I even tried to help you by setting up the notation. That will not happen on your test. You are responsible for knowing that this is your end behavior notation. All right? Now, I don't know how you do it. When I'm asked a question like this, I like to visualize the graph. So this is the exponential function. So the exponential function looks like this. So, what happens to that function as we head off the page? To the right. What's happening? Positive infinity. Now, what happens to it as we go left off the page? Now, some of you said negative infinity. Negative infinity would mean it's going down like this. Is that what's happening? No, what is it doing? It's getting closer and closer to 0. 0. And if anyone had put a little plus sign here, I would have given bonus points. Because there's two ways we can get closer to 0. We can get closer to 0 like that, and we can get closer to 0 like this. This is from the top, from the positive side, and this is from the bottom of the negative side. I didn't require that, but I was going to give a bonus if you got it. All right? All right, let's get back to our review sheet. We're almost out of time. So, I can't remember honestly. Let's do that other piecewise function. So this is 3A. All right, so here we go. This is 3A, another piecewise function. So this one is going to be broken at 1. So that's where my dots are going to be. My dots are going to be somewhere on this line. All right, what does x plus 2 look like? X plus 2 is a line, identity, version of the identity, moved up to. That dot will actually be closed in this time. And I'm going to keep side of it. What's that? It's a line. Y-intercept is the origin, and it has a slope of -2. So it looks like that. Jimmy
Sorry. Open circle, everything's.
crosses right here and it's open. I'm gonna keep this part of it and erase this part of it. I can get rid of this if I want. And there it is.
Can you keep the line?
It's not an asymptote. It's where the picture is from. All right, so what else do we have? I can't remember what we. What else?
Builder.
7. What is an even function? Symmetry
Symmetrical.
along the y-axis. And it means that when you plug in a negative, it doesn't have it included. It's the same. What is an odd function? When you plug in a negative, it makes your answer negative. It has symmetry to the origin. What's a removable discontinuity? A hole? It's a hole. Why is it called removable, do you think? How do we get it? We canceled. We canceled it out. That's why it's called removable. What's a non-removable discontinuity? Vertical asymptote. It doesn't cancel out. We're stuck with it. What is the impact of the 2 and the 3 in this little function here? 2 takes us right 2, and the 3 takes us down 3. So what would number 9A look like? A V vertex at the point 0, 2. What would B, number B look like? A parabola, right one. And what would C look like? A sine curve, down 1. So these are a little harder to draw for most of us. So here is my regular sign. Remember that a regular sign bounces back and forth between 1 and negative 1. Now I'm going to take that picture, that whole picture, and drop it down 1 unit. So now it's going to bounce back and forth between 0 and negative 2. So there's your starting. So this is what it's. Number 10. These strings I just graphed. Bounded above, bounded below, or neither. All right, what about this guy? Bounded above? No. Bounded below?
Yes.
At y equals 2?
Yeah.
That's the 4. In order to be bounded in general, you have to be both, above and below. All right, so what about this one? Above? No. Below? Y equals 0, that's the 4. equals -2. Found it?
Yeah.
Yes. It is entirely contained in that variable. What is the domain of problem 1A? Domain -1 to infinity. Bracket it -1 to infinity. What's the domain of these? All reals negative infinity to infinity. What about C? You guys, I know you cannot wait to get to your next class. I don't know why. I don't know why you think it's more fun than this one. It breaks my heart. But this is not excellence, okay? Excellence is not starting 3 minutes before to gather everything up and turn your brains off. That's not excellence. Come on. I'm agonizing over your performance on that quiz, and you guys don't give a care. Come on, we're better than that. We are excellent. And I mean that with all seriousness. All right, have a good day. I'll see you tomorrow for our final review. Come with questions. If you have homework not turned in, you need to get it turned in. What does that mean?
This was like the difference between
So that has to be a right first, because that's not right, so that is. I know what you mean, but it's not right, and you need to write down exactly. So, because both equations give equations. Nowhere on here did you say that if I plug in negative x, I get the same function. If I plug in negative x, I get the opposite. That's the explanation, not this right here. What equations? Okay? So focus on using the vocabulary that I'm using. What you're explaining. If I do, it's back there. Yes, we have office hours. If I don't have a meeting, we have office hours. So we have office hours. And we have them today. And we have them Friday. All right, now I have to go sit.